Hello and welcome to 5-Minute Math. Today we are looking at day 3 of our 4th grade math review. As always, we are using the released items from the 2017 STAR test for the state of Texas. So today we're looking at comparing fractions, and then we're looking at fractions and decimals on a number line. So this first one is a little bit tricky here. Trevor jogged the following fractions of a mile last week: 3/4 of a mile, 5/10 of a mile, 4/5 of a mile. And then which comparison of these fractions is true? So 3 of these comparisons are incorrect. 1 is correct. And comparing fractions for the first time in 4th grade is done without pictures sometimes. You still might have a picture or two, but you have to be able to compare fractions without any pictorial representation. So what are we doing with these 3 fractions? Well, the simplest thing is going to be able to find the least common multiple. We're going to use that as our denominator. So for least common denominator, so look at my 3s, look at my 5s, excuse me. I don't have any 3s. I've got my 4ths, I've got my 5ths, and I've got my 10ths. So if I were to list these multiples out, if I were to do, let's do the first 5 of each. 5, 10, 15, 20. You know what? I noticed 20 on these two, and I'm going to see 20 right here. So if I could change each of these fractions into 20th, that would make my job so much easier. So let's start with 3/4. 20 is going to be our least common denominator, and we can easily compare these fractions once they all are changed into equivalent fractions that have 20th as our new denominator. So I'm going to multiply 3/4 times something, and I want to end up with 20ths. So looking straight across, multiplication in fractions is really simple. You go straight across. 4 times what makes 20? Well, that's a multiplication fact. That's 5. And if the denominator is 5, the numerator is 5, because 5/5 equals 1. Anything times 1 is the same number. Like 10 times 1 is 10. 20 times 1 is 20. So 3/4 times 5/5, which is really 1, is going to be the same number. I'm just making it look a little bit different. So 3/4 and 15/20 are equal fractions, but that 15/20 is going to be helpful. Let's do the same thing for my 5/10. I'm going to multiply it by something to get 20ths. 10 times 2 makes 20, so I'm going to do a 2 right there. 5 times 2 is 10, which makes sense. 5 is half of 10. 10 is half of 20. Then I'm going to get my 4/5 here. I'm going to multiply that by something to get me the 20ths. 5 times 4 makes 20, so 4/4, and that's 16/20. So now I have equivalent fractions. And so now I can rewrite this f. So my 4/5 is 16/20. Is that less than my 10/20? No, that is incorrect. It's greater than. My 4/5 is also 16/20. Is it less than my 15/20? It's extremely close, but it's not. My 3/4 is my 15/20. My 5/10 is my 10/20. Nope, all 3 of the first ones are correct, or incorrect, F, G, and H. Let's really hope our J is correct. So a 3/4, 15/20 is less than our 4/5, 16/20. Now this is correct. 15 is just barely smaller than 16, so our answer is going to be this J. Now, there is a shortcut. There is an algorithm. It's called the butterfly method that uses the relationship between numerators and denominators. It's good to know as a shortcut, but you need to be able to do this first. So don't just learn the butterfly method without learning how to do it the long way. But once you figure out how to do the long way, sometimes the butterfly method might work for you. So what you're doing is you are taking each of the denominators and multiplying it by the numerator. And you're always going to put it up above the numerator. So 4 times 10 is 40. 5 times 5 is 25. So can you read 40 is less than 25? Nope, that doesn't make any sense, so that is incorrect. So we've got this, you go on diagonal, 4 times 4 is 16. 5 times 3 is 15. Can you read 16 is, you have to keep the sign there. 16 is less than 15. Nope, that's incorrect. 3 times 10 is 30. 4 times 5 is 20. Can you say 30 is less than 20? No, you cannot. The only one that works is going to be this J. That's going to be 15 is going to be less than 16. That is correct. So that's a whole lot of work, but that's a very important skill that you will be using in many years to come. We're looking at comparing fractions again for our second problem today, number 23, but this time they give us a pictorial representation. So let's go ahead and name these fractions here. It looks like we've got 5, 6, and 6 12ths. Let's just make sure. 1, 2, 3, 4, 5. If that's got 5 out of 6. And then I see 1, 2, 3, 4, 5, 6 that are shaded. Every other one is shaded, so let's double that up to 6 12ths. How do we compare these two? Well, we can go back and we can do it. The visual picture doesn't really help us because they're different sizes, and these ones are all spread out, so we need to do the same thing. We're going to need to find our least common denominator of our 6s and our 12s, and that's going to be pretty easy. Look, 12 is on both lists, which means I don't even have to change this fraction. All I need to do is find a multiple of 5/6, or equivalent fraction that equals 12. So 5, let's see, 6 times 2 makes 12, so that's going to be 2 over 2, so that's going to be 10 12ths. So my 5/6 is going to be 10 12ths. And so what we could do is we could just kind of replace this with, could we say 10 12ths is greater than 6 12ths? Yes, we can. That's going to be it. There, 10 12ths definitely does not equal 6 12ths. That's incorrect. And 5 6 10 12ths, 5/6 is definitely not less than 6 12ths. And then D, just they needed a fourth option, so that's not it. Let's check our butterfly method, make sure we have this correct. 5 times 12 is 60. 6 times 6 is 36. So we're going to say 60 is greater than 36. Correct. We're not going to say 60 is equal to 36, and we're definitely not going to say 60 is less than 36. So our answer here is A. And then we kind of shift gears a little bit. We've been looking at number lines for many years now. In the 4th grade, we start looking at number lines as distances from 0, because we're starting to look at decimals. As you can see, we have 2.98, or 2 98/100ths. We have fractions, we have improper fractions, but we need to know where exactly would this 2.98 fall. Well, this 2.98, what's the nearest number that's between? It's between 2 and 3. Well, think about it like you had money. If you had $2.98, is that closer to $2 or $3? Well, you know that this is really close to $3. We're only 2 pennies away. If I get 2 more pennies, I'm going to have $3. So we need to find a picture where it looks like my Q, which is 2 and 98/100, is really, really close to 3. It's only 2/100ths away, or 2 pennies away. And so this has got the Q just a little bit past 1. This has got the Q between 2 and 3, but that looks almost more like 2.5. It's halfway through. That's not going to work. This H is almost correct, but it's on the wrong number. It's a little bit before 2. We need it to be a little bit before 3. It's going to be this J right here. It's just all the way up against 3, just a little bit before, and that's what this 2.98. So that's what this standard asks students, is to be able to recognize where these numbers fall on a number line. So if you enjoyed that and you want to see what's coming up on day 4 of our 12-day review of 4th grade mathematics, make sure to check out my website for tomorrow's post, aarondaffern.com.